Hi, everybody, and thank you for joining us today for our fifth and final installment of our 5 Live series, and that is the 10 Commandments of Spray Foam. Probably going to be a little bit closer to 15, but we think you'll enjoy it anyway. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost, we are presenting from home. Like many of you, we are working in an at-home environment right now, and so if we run into any technical difficulties or if there's any weird background noises, we will take 5 minutes to pause the presentation, see if we can correct it. If we cannot correct it in that time frame, we will cancel today's presentation and send you a recording of it to watch on demand. Now, before we get started, we will be answering all of the questions that you submit at the end of the presentation. So if you would like to submit a question, you can do that via the Q&A feature, and you should see that to the right side of your screen. Now, if you don't see it on the right side of your screen, just simply wave your mouse over the center of your screen, and it'll open a series of circular icons across the bottom. There's one with a question mark in a box. That's your Q&A icon. So if you click on that, that will open the dialog box on the right side of your screen that you can use to submit questions. Also, before we get started, this webinar is for educational purposes only and shouldn't be used as a substitute for professional engineering design, consultation, or documentation that might be required by your building codes, contracts, or applicable laws. So if you have any questions after the webinar, you can refer to our specific application guidelines and instructions, and those are located in the product sections of our website. Also, for any of the tools that we refer to today, please refer to your owner's manual for specific equipment operations that we'll discuss during the webinar today. Finally, we are going to follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we did today. You can use a survey to ask any additional questions you may have about the topic of the webinar, or even suggest new topics for future webinars that you'd like to hear. This survey is also part of how we deliver the JAM experience to you. Now, if you look in the bottom left corner of your screen, you'll see the four values there: people, passion, perform, and protect. And those values are part of the JAM culture here, and those are key components to the JAM experience. But part of delivering that JAM experience to you is making sure that we are hearing and understanding what your needs, and so it's not just a one-way street. So if you have any suggestions as to how we can better achieve this, or maybe you even feel like we missed the mark today, we'd encourage you to fill out the survey, and we'll use your feedback to make these webinars better for you in the future. Now, we're also frequently asked whether or not we send out these presentations upon their conclusion, and we don't send out the presentation itself, but we will post a recording of it online for you to watch at your leisure or share with your colleagues. And this ensures that you can have the presentation within its full context. So we'll send an email to you, and that's live on our website. So with that, I'm going to hand the ball to Wyatt Stevens to introduce himself.
Good afternoon, everybody. Wyatt Stevens, Senior Field Technical Specialist for Johns Manville. Pleasure to have the opportunity to chat with you today as we wrap up the 5 Live series in the webinar group for TechConnect and chat with you guys about a couple of things that we've learned in the field as a result of working with our different customers, and really what we're going to do is share with you today the issues that we found that are frankly the problems that will cause a customer to either end up not being able to continue or having a down day, and these are simple fixes that when these rules are followed, what we hope is that the result of that is that your day-to-day goes smoothly and the equipment operates smoothly and spray goes smoothly. And so we'll just kind of jump in and share those things with you. The first thing that happens with customers that causes them the most grief, and this is certainly more of a wintertime issue than a summertime issue, just has to do with material temperature in the drum. And what happens is that when the material gets below 60 degrees, like syrup or honey or anything else, that material is going to start to thicken up, and it just becomes too viscous or too thick for the transfer pumps to dependably transfer that material from the drum to the machine. What we see here on this slide is the relationship between what we call centipoise, and centipoise is just a fancy term for thickness, and the relation between centipoise and fluid temperature. So you'll see here at 75 degrees, and this is what we call lab or room temperature, the A side is 250 centipoise, and this B side is honestly a little bit generous at just 650 centipoise. Depending on the system, that could be 900 or even 1,000. Open cell tends to be closer to the thickness of isocyanate, but your closed cell systems will tend to be much thicker. So one of the things that I want to draw to your attention is that as the temperature drops 10 degrees, the viscosity will double. So the A side goes from 250 to 500, the B side going from 650 to 1300 in this representation. And notice that at 60 degrees, the B side is already 1,950 centipoise, and that is too thick to dependably transfer that material using the traditional 2 and 3 to 1 stick pumps that are available to us in the spray foam industry. The A side, while at 60 degrees, it's technically still thin enough to transfer, but one of the things that we don't want to forget about is the delta T, or temperature rise capability of the machine. And your machine, it is only capable of raising the temperature 50 or 60 degrees. So even though the A side could be used at 50 degrees, because the delta T of the machine, we can't use the material at 50 degrees. The machine's only going to get it to 110, and we may need it to be warmer than that during the winter months. As we warm up the fluids, notice that as we go from 75 to 85, the viscosity cuts in half. A side goes from 250 to 125, B side 650 to 325. We carry that on up, and as we hit 115 degrees, the viscosity of the A side is now only 16 centipoise. That's a material that's relatively thin, lends itself well to good atomization, to good mix. But rather than stopping the B side at the same 115 degrees, we're going to go ahead and take that B side from 115 to 125 degrees. That's going to bring that viscosity down to 20. Now we've got a differential of only 4 centipoise between the A and the B side. This is going to help balance pressures, and it's going to aid us in adequate mixing. Rule of thumb, 10 to 15 degrees warmer on the B side. Doesn't mean you can't use it at the same temperature, but it's a really, really good practice to run that a little bit warmer so that your pressures will be balanced. We don't start having erroneous E24s or pressure imbalance codes. Talking about the other direction and concern, so that's the idea, hey, if the material gets too cold, it gets just too thick. But if it gets too warm, we can have an altogether different issue with closed cell spray foams, and that is that the refrigerant in the B side drum could actually end up frothing or boiling out of solution and making a mess in the back of the truck. So we don't want to allow those B-side drums to really get above 80 or 85 degrees. Talking about open cell spray foam, it's not common to have that material sitting in a heated room at 95 or 100 degrees, and yet we have some formulations in the industry, and our Appendix X open cell is this way. We need that material to be 90, 95 degrees in order to use it. So it's not uncommon for you guys to be in the practice of recirculating that material through your machine in order to thin out or heat or make that B side the appropriate or usable temperature. Our normal open cell, you can use it at room temperature, 65, 75 degrees, but our Appendix X, you might need to heat. What I want you guys to be careful of here is that heat will break emulsions. Now, emulsion is just a fancy term for a product that's called an emulsifier, and it's used to hold water and oil together. And emulsions can be broken with heat. We've all seen this. We may not realize it, but if you take butter and you stick it in the microwave for just a moment too long and you overheat it, butter is an emulsion. It's made up of oil and water. The two don't actually like each other. And if you microwave it for a moment too long, you'll end up getting back out layers of oil and water. So this same thing can happen in your B-side open cell drum. Let's just be careful that we're not recirculating at temperatures above 110. So looking towards rule number 2 in the spray environment, we really want to talk about the spray environment from a couple different directions. One would just have to do with ambient and substrate temperature. So when spraying on temperatures and substrates below 40 degrees, we just want you guys to realize that that can impact your yield as much as even 15 or 20%. Now, with respect to our closed cell spray foam, we manufacture that product in both summer and winter formulations. We do that to help mitigate the impact of those ambient temperatures, but it's not going to stop you from having a yield loss. So one of the things that we want to look at is, well, what about the options of heating the spray environment? This does two things for us. we're in a happier, better work environment anyway, and then we mitigate that yield loss. So when you look at something like the salamander heater, and that's one way of heating the spray environment, the salamander heater, let's just say we run 8 gallons of fuel through that heater in a day, costing us $25, $30, $35, and now we have a happier spray environment. We get better yield on our foam. We don't have that yield loss, and that yield loss could be $250 on the drum set at 15% or whatnot. The next concern in the ambient environment or substrate environment is having to do with the moisture content of the substrate. Now, this policy or guideline, it's really just exactly that. It's a guideline, and as your substrates start to approach 17% moisture content, we just want you guys to be aware and concerned about adhesion, cell structure, and that the product's performing as intended. I like a moisture meter that's manufactured by a company called Tramex. That's T-R-A-M-E-X, Tramex. The model is a Moisture Encounter Plus. This is a non-destructive model. However, there's a multitude of moisture meters out there and available. What we would like to do is see guys, particularly in wet or moist or humid climates, southeast, we'd really like to see guys having those tools on the job, looking at moisture content in the substrate, and then evaluating whether or not that's impacting the adhesion of the cell structure. The other issue could be with relative humidity. So when we look at relative humidity, we know that we don't want moisture in the air, and we know that moisture impacts cell structure. If that humidity is above 85% and that spray has to travel from the gun to the substrate, that might be 24, 30 inches, whatever the case may be. During that travel time, we don't want enough moisture in the air that it's interfering with the intended formation of polyurethane on the substrate. So as our relative humidity starts to surpass 85%, let's just make sure that again, we're monitoring the formation of cell and the polyurethane foam is forming correctly. This again is also a guideline. This isn't a, hey, at 86%, you're guaranteed to have problems, but it's one of the things we definitely want to watch for. Looking towards service and maintenance, we've got a handful of items here in the service maintenance category. It's really not a lot of service maintenance items, in spite of the fact that we've got this little micro manufacturing plant on wheels that's rolling down the road, and it's got a lot of little moving parts to it. There's actually not a ton of maintenance items. But first and foremost at the front of those is Y strainers. This is the filter basket that sits between the drum and the machine. Its location is usually directly on the machine, right next to the high pressure pumps. But that Y strainer, and we'll look at a picture of it here in a moment, but that Y strainer is something we want to be servicing every 7 to 15 days. So either every Monday or on the 1st and the 15th. And then I just want you guys to be aware that Graco, if we start digging into their manuals, would say that Y strainer is to be serviced daily. I'm not going to take away from that recommendation. They are the equipment manufacturer, but for us, this is based on a lot of history and experience. We manufacture a really nice, clean material. We don't have a lot of problems with plugging up Y strainers, and experience has told us that checking these every 7 to 15 days is sufficient for our material. Looking at the monthly area, we look at the transfer pumps. And on the transfer pump, we have the air motor that sticks out. We're really talking about T1s, T2s, IPM01 series, 02 series. There's a handful of others out there. But on that air motor with the air disconnected, we want to remove the cylinder and the top cap, wipe out the old grease, just freshen it up, put in some new grease, close it back up, and then do that once every month. On T3s, these are a kind of latest, greatest transfer pump. If you're not familiar with them, the reversing switch on T3s is on the outside. It's not part of the air motor, and it's a much more positive reversing. We've been very, very happy with these new style transfer pumps, but they don't have this element of service where you've got to take it apart. However, on T3s, we could be getting some pneumatic oil like used in nail guns or staplers, and just putting 2 or 3 drops in the inlet for the air, let's just say every 3 days or twice a week, where we just put a couple, 3 drops on that inlet. Looking at the pump lube, we'll have a picture of that coming up here momentarily as well, but on the pump lube, we want to be changing that pump lube. This is a little mayonnaise-looking jar that's on the A side of the machine. That material is initially just as clear as water. It's a bit thicker than water, but it's not really very thick at all. And that material, as the machine runs and function, is going to begin to discolor, turn a cream white, a caramel color, and assuming that it's not being adequately monitored, it may even actually start to thicken or turn to a paste. And we want to make sure that that's being changed every 2 to 4 months. It's really just on an as-needed basis, and we let the discoloration dictate when that's going to occur. We don't want to forget about your generator or your air compressor. If you have a manufacturer's owner's manual that suggests differently, you should certainly follow that guideline. In the absence of that manufacturing recommendation, we would just tell you every 200 hours, let's be changing the oil on the generator and on the air compressor. Air dryers, water traps, desiccant cans, these are pieces. If you've got water traps, make sure we're opening and closing those dailies. If you have auto drains on your air compressor, let's make sure that we're cognizant of those. And it's a tip worth mentioning. If you got an auto drain on your air compressor, let's make sure that we're thinking about where we're parking that spray rig. If you pull it onto somebody's brand new driveway and that auto drain kicks off, you're going to have a big rust stain on the driveway. So here's a picture of that Y strainer. Hopefully we're all familiar with it. We definitely don't want it to look like the one on the right-hand side there. This is one of those issues that we see over and over and over again. It can lead to off-ratio foam. It can lead to perpetual E24s or pressure imbalance errors. You can have a multitude of issues associated with having these Y strainers not properly serviced or kept track of. Looking at that pump lube assembly, we want to make sure that that fluid level is between 1/2 and 2/3. The nature of this component is that as the A side pressure pump travels in and out, this material is going to make sure that that environment is wetted out with pump lube and that the moisture is not seen on the outside of the cylinder or on the outside of the piston rod rather. And then we want to make sure that we're filling that up 1/2 to 2/3. There is a natural increase as the iso weepage starts to dilute the pump lube, so we don't want to fill it all the way to the brim, and make sure we're using the appropriate TSL or your supplied pump lube from us, which is called pump lube and can be purchased from Damon in the parts department. Looking towards the heated hose assembly, this is a little issue that certainly comes up on a regular basis, not to the extent that you see here in this catastrophic picture, but the process of heating the hose coiled on the rack is something that happens a lot. And what I want to take a chance to chat with you guys about is certainly there is the risk of fire. This is a trailer that the hose is being heated and it's stacked on top of itself. And what happens in this scenario, we have a singular data point in the A side hose. Approximately 60 feet from the gun is where your thermocouple is. And whatever the temperature is of that singular data point, as far as your machine is concerned, that's the temperature across the entire thing. So when you have the hose coiled on the rack and it's stacked on top of itself, it acts as a heat accumulation. And while the spot where the thermocouple is might be in a 15 or 20 or a 5-degree environment, it thinks it's cold and keeps asking for heat. This section of hose that's all stacked on top of itself is just getting hotter and hotter and hotter until ultimately it melts a hose or in worst case causes a fire. Best case scenario is we actually end up with this issue where everywhere that the hose was stacked on top of itself, it accumulates more heat. Everywhere that the hose is loose, it accumulates less. You finally get ready to spray, you drag the hose into the house, and what happens is for the first 40 minutes of spray time, we have hot and cold spots. And so our pattern's constantly moving on us, and we've got this really well atomized good mix, and then we've got this less than in stellar mix, and it's just all over the place for the first 40 minutes. It feels like the first hour of our day is just difficult to get a hold of, and then things kind of just tend to mellow out. So be aware of that. Let's make sure that the hose is off the rack. We're personally comfortable with one layer left on the rack, but nothing that stacks on top of itself. Having the right tools for the job. This kind of goes without saying, but it's definitely a productivity issue that we see all of the time. Guys don't have a pin vise. You can't really use that tiny little drill bit between your, index finger and your thumb. Making sure you have a 5/16 nut driver, having the right A-frame ladders, everything from 4 foot to 10 foot, and maybe even a small step stool for 8 or 9 foot walls if it's easier to move that along instead of moving along these big A-frame ladders. Having an extension ladder for attic access, scaffolding that has properly functioning wheels, properly functioning brakes, and the appropriate pins to hold those wheels in, that every time the scaffolding's lifted or moved, the wheel's not falling out. Scrapers come in every shape or size, 5-in-1 tools. There's some floor scrapers, some Bully tools that are a floor scraper that work pretty well. Curry combs, if you guys aren't aware and you don't have a horsehair brush on your spray foam truck, you ought to run to your local farm supply and get one. Curry combs are a super, super common for removing the overspray off the face of studs. They're a great tool to have. We're a supplier of a product line called Piranha, and the Piranha lineup, these guys have a handful of tools available to you. They have some scrapers, and they have what we call the Swiss Army knife of spray foam. This is a fold-up utility that has a scraper, a pick, a wire brush, the 5/16 nut driver, all of this that fits right there in your pocket, and it's with you all the time. Great, great tool to have. If you're not familiar with the Piranha lineup, reach out to Damon in the parts department, and he can send you a brochure or a pamphlet and show you what these tools are that are available to you. Having plenty of plastic, tape, staplers. If you have never used tinfoil for masking, we've all had jobs where, quite frankly, the masking takes longer than the spray job. Tinfoil works out really well. If you've got garage running rails, you can pull out a 10-foot long strip of tinfoil, lay it over the top, crunch it, and you're done, and you're moving on. Fire suppression sprinklers, tinfoil is probably the easiest way to mask those. Make sure you've got everything you need for masking. Trim saws, scarfers, they're out there in a multitude of options as well. Changeover procedure. We're not going to spend a lot of time on changeover procedure here today. What I want you guys to be aware of is that we do have an open cell Appendix X formulation. It is not actually compatible with our other B sides. So if you're moving into or out of our Appendix X open cell, you absolutely have to follow this changeover procedure. You can go to jm.com/TechConnect, and you can find a video there on the changeover procedure as well as some written instructions. And if you're going between two closed cells, if you're going between two open cells, if you're going between our normal open cell and closed cell, absolutely recommend following the changeover procedure, but let's not call it quite as required. There's some other options. You could choose to chase out the material with one behind the other. Just know that when you get to that cross-contaminated section, that hybrid material can't go in the wall, got to be discarded of properly. There's some real added costs associated with just chasing one material out with another. That could be as much as $85, $95 in liquid waste, whereas this changeover procedure minimizes that to near none. So again, jm.com/TechConnect. Never, ever, ever flush the A side with water. That's a catastrophic failure. This is a B side only issue, and that's available there if you're coming in out of ROCX. And if you have any additional questions on that, you can reach out to me or to the TechConnect that supports your area. Sealing the drum during use. So we've got two different types of drums out there available for you guys. We have what we're called tight head drums. These are the drums that are almost, well, they're all manufacturers put the B side closed cell spray foams in a tight head drum. These drums do not have a removable lid. They have a 2-inch bung hole and a 3/4-inch bung hole. There is no center bung. There's no place to place a mixer. We're not ever going to mix or recirculate closed cell spray foam. And then on the open cell side, we have that removable lid drum that has 3 bung holes, the 2-inch in the center and the 2 3/4 again. What we want to look at here is the fact that as we drain fluid out of this drum, we have to allow air to come in and displace that fluid as it's leaving. Now, what you see in this illustration is what we refer to as a circulation kit. And this line right here actually runs back over to the pressure relief valves on the machine. And it allows that fluid to come back through a 1/2-inch riser tube, which drops down into the bottom of the drum. And when you open the pressure relief valve, that material dumps back into the bottom of the drum. However, the inlet for air is through this desiccant can. And if you're not familiar with desiccant, desiccant is just a moisture-loving media that is a little blue, kind of almost looks like kitty litter or floor dry, but it's a blue. And as it takes on moisture, it will turn from blue to pink. Now, on the A side drum, it's imperative that we use this incoming desiccant filter to take moisture out of that air so we're not forming crystals or causing a reaction inside of our A drum with moisture in the air. But on the B side drum, it's actually not required or necessary. So what you can do on your B side drum is if you've got this set up, go ahead and use the desiccant can once, but when that filter media turns pink, there's really no need to change it. There's some water in that drum already, so having moisture-laden air come in is not a problem. But that air comes in through this desiccant, passes through this 3/4-inch 90 and into this T right here, and that 3/4-inch T is larger in diameter than this 1/2-inch riser tube. That allows air to pass by that into the drum, and now you're managing that for moisture, and you're allowing air so you don't collapse the drum. At a bare minimum, if you're not set up with this arrangement, just know that when your transfer pump goes into that drum, you've got to at least loosen this 3/4-inch bung so that air can come in and not collapse the drum. I want to talk about the process of spraying off target. And really what we're addressing here is the fact that you've got 200, 300. If you've got a really big machine and it's got 400 feet of hose, you could have up to 400 feet of hose. And all of that hose is preheated or has a heat trace on it. But the very last foot, if it's we'll call it OEM hose, or if you guys have went out and bought 36-inch long whips or whatever the case may be for ultralight and flexibility, and we get that, just know that the last section is not heated. So when you first pull the trigger, you're going to get what we just call a fluid fire hose effect out the front, or a pencil stream that runs out the front, where this material's not thin, it's not heated up, so we don't get good mix out of it. We cannot be putting that inside of the substrate or cavities or on somebody's wall. We need to make sure that we've got a piece of plastic, a cardboard box, a garbage sack, whatever it is that you've got there with you in the spray environment so that you can spray off target. And let's make sure that we know that we're making good foam, good atomization, good cell structure before we take that material and go from that off-target spray and start putting product in somebody's walls. And then during the winter time, if you take a 3 or a 5 minute break, you could actually end up not being able to spray without going off target again. And during the summer, maybe that's 10 or 15 minutes, but have that piece of plastic there. Talking about transfer pumps, really what I want to talk about here is that you got to have the right transfer pump for your machine. So when we talk about T1s, these T1s, they're 2.5 gallons per minute. 2.5 gallon per minute transfer pump doesn't support a 3 gallon per minute machine. So T1s are really only capable of supporting E20s. We shouldn't have those in front of E30s or some of the other larger PMC hydraulic machines. We shouldn't have them in front of an H30 or an H40. We want to be using Graco T2s, T3s, IPM 0232s. But the real key point here is we want to make sure you recognize that the air pressure going to your gun, that's 110, 115 PSI. We can't be running 115 PSI to our transfer pumps because our transfer pumps are 2 to 1 in nature, meaning the air motor is twice the size of the fluid section. So if you put 100 pounds of air pressure into it, you're going to get 200 pounds of fluid pressure out of it. And now we're overcharging the machine and we run the risk of floating check balls. So let's make sure that we've got more than one air regulator on the truck We need a certain air pressure going to the spray gun, and we need a certain air pressure going to the transfer pumps. Depending on the transfer pump, let's just call that somewhere between 60 and 85 PSI. Looking at transfer hoses, the homework's been done for you here by the equipment manufacturers. If you order transfer hose from our parts department, we're just going to sell you Graco transfer hose, and that transfer hose is a polybutyl jacket so that it's as flexible as it can be, but it can lock out moisture as much as possible. So we all know that the A side loves moisture, and that moisture is going to diffuse through your transfer hose and start to solidify that transfer hose from the outside in. So what started out as a 3/4 inch ID hose is just getting tighter and tighter and smaller over the years. What I would like you guys to have is I want you to have the same transfer hose on the A side and the same make on the B side. And when you walk into that rig and you grab that B side transfer hose and it feels really nice and flexible, and you walk over to that A side transfer hose and it's very rigid and firm, just realize that that A side hose is solidifying and it probably needs to be replaced periodically. In the Southeast, that's going to be more common than in Denver or Utah, where, you know, we've got 5% humidity. So just be aware of that, watch it, make sure that we're not solidifying, and then know that if you go down to the local hydraulic store and buy a transfer hose, it may not be the right makeup to lock out moisture. So just be careful with that. Pressure settings. When we talk about pressure settings, we're really, really looking for you guys to have 1,000 PSI at the gun. Now, there's pressure loss associated with the material traveling down that line set. We're just going to take a real generic approach here and say that you lose 1 PSI of fluid pressure for every 1 foot of hose. And so when we want 1,000 PSI at the gun, if you have 260 feet of hose, then we need your pressure back at the machine to be 1,260. That way you can lose the 260 down the line and you still have 1,000 when you get out to the gun. And we're talking about dynamic spray pressure here. So when you have everything sitting still, your pressure is referred to as static. Nothing's moving. And that static pressure is not going to help us know what's happening when we're spraying. So this takes 2 people. You need one guy to pull the trigger. You need the other guy to watch the gauges on the machine. And we're looking for those gauges to fall when the trigger is pulled to 1,000 plus length of hose. The other thing to look at is if that pressure drops more than 500 PSI, there's a really good chance that the gun has a mixing chamber in it that's too big for your machine. We don't want to see more than a 500-pound drop. Looking at temperature settings are your guys' fine control, and it's for fine tuning. We have a label on the side of the drum that says, hey, these temperatures are 105 to 130. We really do plan on you operating within that window. But if we come out and meet with you guys in July and we set your temperature at 105 and 115, come January, you shouldn't still be at 105 and 115. We really want you guys to read the foam, pick the temperatures within that window that works the best for wood's going to be different than steel. Steel's going to be different than concrete. Substrate, ambient temperature, all of these things play into what your processing temperature might be. And if you have to go outside of that window, we need a phone call before you do that. Proper gun setup. Really what we're saying here is right back to that comment we were talking about a moment ago, which is if you pull the trigger and that pressure drops more than 500 PSI, it sounds like that mix chamber is too big. So notice on this list, these are the maximum size tips recommended for these machines. So an E20, it won't really support a 52-52. At the very, very biggest, we want to see you guys in 37 to 42s. In the H25 at the largest, 42 to 52. Now we have the 47 in there, of course. E30s and H30, 52 or 60 at the largest. Just know that we have to make sure that that gun is not configured larger than what our machine's capable of. Pass thickness is a really, really big deal. This one is one where oftentimes the foam looks fine on the way out the door. And then what happens is 2 hours, 6 hours, 2 weeks, or 2 years later, the foam starts to experience what's referred to as a dimensional stability issue. And one of the things that you guys should recognize is that When we spray the foam 1 inch thick in a single pass, and we're talking about we sprayed enough liquid that after the foam grew, it grew to be 1 inch thick, and now it developed a skin. The core density of that 1 inch pass might be 2 pounds per cubic foot. Now, JM Core Bond 3 is intended to be sprayed up to 3.5 inches in a single pass. And if you want to get optimal yield out of the material, then you're going to spray approaching that 3.5 inches on a single pass. And that's fine. And when you spray that 3.5 inches in a single pass, that core density isn't 2 pounds per cubic foot. That core density is 1.75 or something, right? And so when you have that material and you spray it thicker, the density drops. Well, there comes a point where you're not left with enough plastic anymore to actually sustain the normal cyclic nature of daytime, nighttime. So every single day, all of these millions of little cells, they're expanding as they heat up, and then overnight they're contracting. And I want you guys just to take a moment and think about, you know, when you get ready to throw away a credit card, you bend it in half, you bend it back out straight, it's still plastic, it's still intact, you bend it in half again, you fold it back out straight. You do this enough times, and eventually that credit card breaks in half. The same thing would happen with metal flat strap. So when we talk about the cyclic nature of this foam expanding and contracting every single day, we need to have enough plastic content there that it doesn't experience dimensional stability issues long term. Now, if you've got a job and you need to climb through the trusses and you're trying to apply 5 inches to the underside of that truss, that's fine. We have an approach for you that we call single sitting. And in a single sitting approach, we're really saying there's a trade-off here between labor and we'll call it optimal yield. And I get it. Nobody wants to climb through the trusses twice. So that's fine. Jump up there. You can do a 4-inch job in 2 2-inch lifts, no cooling time required. You can do a 5-inch job in 3 approximately 1.7-inch lifts. Now, the core density of these 1.7-inch lifts, they're going to be higher than the density if you had done a 3-inch lift and then a 2-inch lift or 2 2.5-inch lifts. So when you spray those 1.7-inch lifts, your density goes up, which means your yield goes down, but you only had to climb through the trusses once. In addition, you used 3 passes, and the knit line that forms adds density of 0.1 or a 5% reduction in yield. So this approach right here may actually cost you 10 or even 15% on yield, but you have a labor savings associated with not climbing through the trusses twice, and there's certainly a safety component there that we don't want to ignore either. So single pass, single sitting, 3 inches in a single pass, up to 5 inches in a single sitting, using this approach. And then I just want you guys to be aware that we've got a couple of industry consultants that regularly go out and are used to look at foam failures in the field. And these consultants have told us that in the past 2 to 3 years, they've seen more dimensional stability issues in this industry than in the prior 20. And there's certainly a trend right now to try and push this envelope in pass thickness where they're saying, hey, the foam doesn't char. And it's fine that the foam doesn't char, but that doesn't mean that it's dimensionally stable, that there's enough plastic left there to withstand the day-to-day cyclic nature. So understand ultra-thick, low compressive strengths, potentially poor dimensional stability, potentially high open cell content, and a lower than label bar value. Just something we want you guys to be aware of and make sure that you're taking your reputation as your company into the field the way that you really, really want your company represented. And then a last little point here, it's not on the golden rule list. It's just something to keep in mind and know. There are fuel additives out there. Most all of our generators are diesel. This is interesting information for a lot of folks. They've never seen a true study around this. And what you're doing is taking these diesel fuels, and at 50 degrees, the paraffin wax that's in diesel is in solution. It hasn't fallen out of solution or gelled. And what happens is, as diesel cools, that paraffin wax can fall out of suspension. So when you look here, you can see that there's a phase separation. This is bad. This is bad. This one's cloudy, but it's cloudy from top to bottom. And so it's actually the best treatment for this diesel fuel. And understand that this is the diesel fuel bought at the Chevron over in this county. They have additives during the wintertime, but it's not the same for everybody. And it's not to say, hey, Schaefer's works the best with every diesel fuel. That's not going to be the case. if you're experiencing issues during the wintertime where your generator will only run for 30 minutes before it plugs up fuel filters, this is definitely something worth doing, where get your local diesel wherever it is that you fuel at, get it in some small containers, stick it in your freezer, and buy 3 or 4 different diesel additives and see which one is keeping the paraffin wax in solution. And with that, I'm going to turn it back over, and appreciate your guys' time and your attention, and we've really appreciated the opportunity to work with all of our customers out there with this 5 Live series and trying to take advantage of the fact that we're all at home. Thanks so much.
Great. Thank you so much, Wyatt. So if you could hand presenter privileges back to me really quickly. And I'm going to start talking about some resources while Wyatt does that. First and foremost, we do have our TechConnect team, and they are located throughout the United States. So, Wyatt handles the West Coast, but we also have a variety of other experts that helped present this TechConnect 5 Live series for you over the last 5 weeks. So you can contact us, any one of these people, via these direct phone numbers if you are in their area, or you can actually just reach out to our TechConnect online on-call on-site team, and you can reach them at 1-800-654-3103. And this is a resource for JAM customers who might have any technical questions. Maybe you're having some trouble with spray foam, blowing wool. Maybe you have some questions about the materials, your rig. This team is a resource for you. So feel free to use them if you have any questions or concerns. And I did want to talk about this is the last of our 5 Live series. All of these webinars are now available on demand, and today's webinar will be available next week on demand. And you can access them through our website. This Thursday, we also have the conclusion of our AIA certified webinar series, and that'll be on the 30th. We'll be talking about continuous installation. So if you do have any questions about that, this is a great kind of crash course in continuous installation. It will be hosted by Jerry Fox, and that will be on this Thursday, April 30th at noon Mountain Time. So with that, we're going to take it to some questions. The first question, Wyatt, is why is JAM Core Bond so much more expensive than like products?
Sure, yeah. It's a question that comes up, I'll call it relatively often. And one of the things we want to make sure that we realize is that usually when somebody says more expensive, they're really talking about from a cost per set perspective. And there's a lot that goes into this. And what we really want to look at is we want to make sure that we're doing a comparison where we say, okay, product A gives me 4,200 board feet, product B gives me 5,000 board feet. That's to say I bought the same 1,000-pound set, but this product actually covered 800 more board feet. There's 2 things there. That 800 board feet, that's nearly 15%. So let's just say that every moment the guy's pulling the trigger, 15% more work's getting done because the foam's growing 15% more. The other piece of that is R value, and that is if I have to use 4.3 inches of product A to achieve the R28, and I only have to use 4 inches of product B to achieve the R28, well, then there needs to be an adjustment made there too. So it's definitely one of those things where we want to make sure that we're talking about cost per board foot, and what happens is when we go out and we do that side-by-side sort of challenge, as we look at these 2 products, we find that while the drum set might cost more, the actual installed cost is usually the same, if not cheaper, with Core Bond 3.
Excellent, thank you. The next question is, what are the potential consequences of cross-contaminating during a changeover procedure?
Okay, sure, yeah, sorry about that. Could have covered that a bit better. So one, going back to that little recirculation kit, make sure that you realize that 10-foot, 20-foot chunk of hose, that still has product, number 1 in it. So let's make sure that we're not opening up that pressure relief valve and dumping that whole line set back into product 2's drum and cross-contaminating. But the open cell and closed cell, they're 2 very, very different products in nature. And you can actually see if you get a little bit of water content in closed cell or open cell in closed cell, it'll actually blow the cells and you'll see these fish eyes and blisters. And when you have that, okay, it's really, really evident that's cross-contaminated, and you know not to use it. Where you can have a bigger problem is when you maybe switch from one closed cell to another closed cell. And just maybe one of the things to be aware of is that our analytical capabilities today, reverse engineering and things, and, when you sit down and watch, NCSI or whatever, and you watch this, creative liberty movie that shows all these equipment and all these amazing things they can do, it's not totally far-fetched. So when we take a foam sample out of the field that exhibits an issue in the case of perhaps dimensional stability or maybe open cell content, or maybe it's cracked and come off the substrate a little bit, there have been a number of instances where we've taken that product, brought it back, ran it through our analyticals, and we're like, hey, we appreciate the fact that there's definitely some core bond 3 there, but definitely there's this product there as well. And then inevitably they come back and go, well, yeah, that was the product we were switching out of. And it's like, well, that's one of the reasons to follow that changeover procedure, so that you have that water scrub on the B side and you're absolutely certain that you don't have that residual material resting in the lines to potentially cause you some problems. As far as what it would be, sure, it could be dimensional stability, it could be cracking, it could be open cell content, it could be a poor compressor strength. Well, most of those aren't going to be observable to the naked eye, but it's just something better avoided. Make sure that we're doing an adequate flush if we're changing between systems. Hopefully that answers that question.
I think it was an excellent answer. The next question is, what is pump lube?
Okay, pump lube. Probably Wyatt's personal pet peeve. I hate that we call it pump lube. It's not a lubricant. What this is what's called a plasticizer. And a plasticizer is really just a liquid medium that is not reactive with either isocyanate, and it's not reactive with the B side either. But in this case, we're using it for the A side, right? And it's just a liquid that absolutely has zero propensity for taking on water. So there's a term referred to as water solubility. And if we dig into different safety data sheets and metrics for different chemicals, we'll find that their propensity for taking on water, their water solubility is X. And so in the case of pump lube, dioctophthalate, mesomol, throat seal liquid, these plasticizers, their water solubility is decimal points down, 0.0000381, or whatever the case may be. They just really don't have any ability to take on water. So we're really creating this bath of this water-hating substance that, as the A side pump comes in and out of its cylinder, that piston rod is seeing this environment that cannot take on moisture. And I'll go ahead and expand that to say, you'll hear some pretty crazy ideas out there. You can flush with hydraulic fluid. You can flush with transmission fluid. You can flush with diesel fuel, of all things. And that, these other products actually have some water content in them, possibly. In the case of diesel fuel, there's definitely water in it. In the case of transmission fluid, in the case of hydraulic fluid, these chemicals have a much higher propensity for taking on water. They still don't love water, but they have a much higher water solubility rate than pump lube. So bottom line is, nothing else belongs in that A side jar besides pump lube. And frankly, no other medium should be used for flushing your A side system should you ever need to do that besides pump lube.
Well, that sort of answers the next question, which is, can I flush my A side with diesel fuel?
Definitely not.
Simple enough. Is there any concern about what kind of heat I should use?
Any concern about what kind of heat I should use? So I suspect that question's really talking about the ambient. So if it's 25 degrees outside, what can I heat the area with? So in the case of the salamander heater, that puts out a nice dry heat. Natural gas puts out a nice dry heat. It's probably lending to the fact there's certainly some buzz in the industry, and it's well understood by a lot of people. You cannot use propane. So propane puts an absolute ton of moisture in the air, and we don't want to be using propane as a medium for heating the spray environment. We don't need to add that extra moisture.
All right. The next question is, Wyatt mentioned using heaters for the substrate in cold temps. Are certain heaters better than others?
So, yeah, I think that just goes back to that prior conversation. So something that puts out a nice dry heat, either natural gas or something like the salamander heater that puts out a good dry heat. Electric heat would certainly be fine, just don't know how feasible that is.
All right. The next question is, what would cause the use of more A-side than B-side and vice versa?
Okay, so let's hope that we don't necessarily ever have the vice versa. So the more use of A-sides, a question that comes up or an issue that comes up pretty regularly, and really what it is not that we're using more A-side, but that there's a difference in what's called specific gravity. So we know that water weighs 8.34 pounds per gallon or whatever it is. I think it's 8.34. And our fluids that we use in spray foam weigh between 10.5 pounds per gallon. Some B-sides maybe as low as 9.5. So the isocyanate weighs 10.5 pounds per gallon. And the B-side, in the case of like Corbon 3, let's just say it weighs 10.2. That's pretty close, but it's not exact. Our open cell is much lower. And so in the case of open cell, because there's such a radical difference, we don't put 500 pounds in the B-side drum on the open cell. We actually put less. But we're selling you drum sets as 500 pounds and 500 pounds, not 50 gallons and 50 gallons. The fluid levels are actually like 48.5 and 49.2 or something. And so about every 30 drum sets, you're expected to need an extra B-side drum. And it may sound a little bit hokey at face value, but the reason we do that is during the drumming process, these materials can be kind of frothy. And the problem with volumetric meters is that volumetric meters see entrained air as volume, whereas weight is weight is weight. So even if the material is frothy during the fill process, by filling the drums to 500 pounds, you're getting your 500 pounds. So it may not be that they're actually using more A-side as the fact that there's just different specific gravities for the two. If you are in fact using more A-side, that is a huge problem and something that we should definitely chat about on a one-on-one about what's occurring.
On that note, if you do need to contact us to chat about using one side more than the other, you can definitely contact us at this phone number here. So I just wanted to bring that back up so everybody has access to it. The next question for you, Wyatt, is does it take longer for Gen 4 to raise than other spray foams?
Yeah, so absolutely. They tend to be a little bit slower in nature. The refrigerant that's in our JM Gen 4 has a boiling point of 90 degrees, whereas the refrigerant that's in our Corbon 3 has a boiling point of just 60 degrees. So when we spray this fluid out the front of the gun and we're using the heat, the mechanical heat in the machine, we're setting our temperatures 120, that's to help kick off that refrigerant and have it phase change from a liquid to a gas. That when we say boiling point, we're really saying, hey, it changes from a liquid to a gas. That's what blows the cells. So the nature of having a refrigerant that doesn't boil until 90 degrees means that it is going to kick off a bit slower. And so it is observably slower in terms of its response. Now, ultimately, the growth tends to be pretty close. The yield on the JM Gen 4 is not as good as the yield on the Corbon 3, and quite frankly, the yield on Corbon 3 is not as good as what would have been Corbon 2. As these refrigerants have evolved and changed over the years, my opinion doesn't mean that everybody's going to share it, but my opinion is that each resulting spray foam's frankly probably been not quite as good as its predecessor in terms of sprayability and usability. In terms of the finished plastic, that piece is different, and that has experienced a number of improvements over the years. But in terms of sprayability, they tend just not to be as friendly to use as their predecessor.
All right, and our final question is, what is the ideal depth per pass when spraying Gen 4 spray foam?
Ideal depth per pass when spraying Gen 4. Ideal might be a subjective term. A lot of it has to do with the intended installed finished thickness. If I've got a job that I'm going after that is 6 inches, in reality with our JM Gen 4, we could do that in 3 2-inch lifts, but there would be a loss in yield. So if you were saying that I still have good control, I'm still laying down something nice and smooth and it looks aesthetically pleasing, but at the same time I'm not getting carried away and I'm not killing myself on yield, I'm going to say 2.5 to 3 inches. But with our JM Gen 4, you can spray it up to 4 inches in a single pass.
Excellent. Well, Wyatt, thank you so much for the insights on all these questions today. And for everybody who attended, thank you very much for joining us. We hope you found our TechConnect 5 Live series relevant and helpful and useful, and you're able to access our on-demand webinars as you need them. We will wrap up here today, so thank you everybody for joining us. Take care and enjoy the rest of your week.
Thanks, everybody.